Hello friends, today we'll look at wavy curve method, which is a very important topic in mathematics, and it's a very easy, very interesting, and even a very scoring topic if you understand the basics. So we try to cover everything in this video about wavy curve method. Everything. I mean, obviously we'll not be able to give you enough practice, but please watch the video. This is a method to solve inequalities. At a basic level, 7 inequalities 2x minus 7 is let's say greater than 9, then yeah, we'll get an even number. So 2x should be greater than 9 plus 7, which is just 16. So x should be greater than 16 over 2. That means x should be greater than 8. Now x is greater than 8, that's not a single value, that's like a range of values. Any positive integer which is greater than 8 will satisfy this. And if I put an equal to sign here, in that case our answer would have been x greater than equal to 8. That means x is exactly equal to 8 would also have been a solution, and any greater values will also have been a solution. Okay, so the thing is that how to represent this? You may keep this as an answer, but how to represent this more nicely? For that we need the concept of intervals, which is a very important concept. Say I have a number line here. Okay, so let's say this point is 8. So if my answer was, let's say this is case A, x greater than equal to 8, and say we have a case B, which is just x is greater than 8, and say we have a case C, x lesser than 8, and say we have a case D, x lesser than equal to 8. Okay, so in case of case A, x greater than 8, that means all values greater than 8, I mean this range. So we represent it like this. Okay, and should we include this 8? Yes, we should include, because if x is exactly equal to it, then also that will satisfy the solution. So if we have to include this point, we just draw a hollow filled circle here, like we just like a dark filled circle. Okay, and how can we write this? 8, from 8 to infinity, this is just going on to plus infinity, and if it was in this side, then minus infinity. So from 8 to infinity, as we have to include 8, we keep a square bracket here. But see, infinity is not a particular number, so can we include infinity? No. So whenever there is infinity or minus infinity, we put a curved bracket, parenthesis. This is the open interval, this part, and this part is a closed interval. Okay. For case B, our figure would be, say this is our number line, this is 8. Here we draw a hollow circle, I mean this sort of circle, not filled, we will not fill in the circle. Hollow circle indicates we should not include that value, we should not include the value of 8, but all other numbers greater than 8 should be included, because in this case x is just greater than 8. So x is equal to 8 is not will not satisfy this equation. And in this case we just write from 8 to infinity, but we put a curved bracket before 8, that means 8 should not be included. And if x was lesser than 8, then say this is our number line, say this point is 8, so all these values, and if x is only lesser than 8, then our open circle, that means from minus infinity, this is actually coming from the left hand side, so from all the way from minus infinity to 8, from minus infinity to 8, and both open brackets, because we are not including 8. And if we need to, if it was lesser than or equal to 8, in that case a closed bracket here, and this would have been from minus infinity to 8, but after 8 we would have a square bracket. This is the basic idea, like basic thing how to represent your answer. Okay, now the thing is that let's solve one more. First of all, we took this like 2x minus 7 greater than 9. But if it was 7 minus 2x greater than 9, or let's say greater than equal to 9 to make it more interesting, what would it have been? See, in this case the coefficient of x, I mean before x we have a negative sign, but this was not. Here it was plus 2x minus 7. So what to do in this case? Okay, let's try. Minus 2x should be greater than equals to 9, greater than equal to 9 minus 7, which is just 2. Now, yeah, we can divide both sides by minus 2, but yeah, if we're dividing by something negative, I mean if we have a negative before x, in that case we need to change the sign. So if we divide both sides by minus 2, x, and in the RHS we will have 2 over minus 2, which is just minus 1, but in this case the sign will become lesser than equal to. So our answer to this question, to this inequality, will be x lesser than equal to 1. Okay, I hope I'm clear. X lesser than equal to 1 in this case. Now before we move on to wavy curve method, let's be fast, okay? Before we move on to wavy curve method, I'd like to give you one simple idea. I hope you know knowing the basics of sets, which is a very important and interesting concept in mathematics. So let's say this is universal set. Universal set, I'm not going to details of set. Just assume that there are two sets A and B. This is set A, this first circle, and this is set B. Inside another rectangular set, which is usually called universal set. You don't need to know the concept now here. There are many concepts: universal set, null set. Anyway, so anyway, what should be A union B? This is the symbol for union. It looks like U, but it is not this. Okay, it's just a like this symbol. So A union B is basically the region I'm shading out. Okay. This region. A union B is basically the region, the both, that means I have to consider both A and B, right? Both A and B. But I cannot count a single region to that. So basically there are three regions. One is this region here, this region, which is common only to A. One is this region which is common only to B, and this region is in between. This is called actually A intersection B. This is the symbol for intersection. Okay, like it looks like small n basically. So A intersection B means the region which is common to both A and B, which is obviously this region in between. But for if you want to find out A union B, so let's say A, okay, that's this entire circle plus B. But if we do A plus B, then we have to, actually this is the number of sets in A, n of A, and I mean number of elements in A, number of elements in B, minus n of A intersection B. Why? Because see, once we are counting A, I'm just drawing it once more. So let's draw it more clearly. Right? This is A and this is B. So once we are counting A, that means we are counting this region also. I mean, let's just put a dot here, otherwise it will look untidy. I am counting this region also, I am counting this region also. Now when I am considering B, I am counting this region also, I am counting this region also. But this region in between has been counted twice, so we have to eliminate one of them. That's why minus A intersection. But this region is basically A intersection B, right? So that is the concept of intersection and union. But if we have a number line, then the concept will be a little bit different. Okay, I'm just showing you the basic idea. Suppose I have a number line here. This is A, this point is B, this point is C, this point is D. Suppose my answer is I have to consider all the values from A to B, and I also have to consider all the values from C to D. So there is a gap in between. Now how can I represent this as the answer? Then from A to B, and let us assume that these are open circles for now, for simplicity. They may be closed circles, so it depends on the question. So we'll put this sort of bracket. Union, sorry, not intersection. Union C comma D. Okay. So this is how we have to put it. And if we had to take intersection, for instance, if we had this sort of value, okay. Okay, let's do the same figure itself. Okay. So suppose this is A, this is B, this is C, this is D. Suppose I have some here A to C, I have a range of values, and from B to D. So what will be the intersection of these two? What will be the intersection? Further, you see in this region from A to B, you see I have only one line, I mean only one range of values, that is this one here, of the first function, of not the function of the first set of values. From B to C, you see I have this line also, this line also. That means this is the part, this is my answer. That means from B to C, and let's assume these are open circles. So this is actually the intersection. I hope you are clear with the basic idea. And yet in this case also I have this, but I don't have this. Now let's, without further ado, let's move on to wavy curve method. Wavy curve method. Okay. Well, now let's consider example x minus 3x plus 5, or say x minus 5. See, this basically it's a polynomial expression. If you distribute it, you'll get a quadratic polynomial. Let's say this is greater than 0. Let's keep things simple for now. So what you can write it, this is x square minus, but the thing is that we have some conditions. We can apply wavy curve method when and only when the LHS is factorized. Factorized means it's like see this expression, it cannot be factorized anymore. It is in its simplest form, factorized. So it is satisfying the first condition. Second condition is RHS must be 0. This is not an equation, but yeah, this is your LHS and this is your RHS. So RHS must be 0, otherwise you cannot apply wavy curve method. If the RHS is not 0, you have to make it 0. We'll do such examples also, don't worry. And one more condition, just to check, what was that? Yeah, coefficient of x, that's a variable, can't be negative. If it's negative, you have to multiply -1 to both the sides, and then that will give you positive, but you have to do the sign change also, because I'm multiplying -1, can't be negative. That's the basic thing. Okay, alright, let's keep these points. So how to solve these kind of questions? You see, basically first of all you need to understand the concept of critical points. This is nothing hard, I'm just telling you in one single sentence. Critical points are, first of all, draw a number line. Critical points are those points on the number line at which this expression becomes 0. For instance, if I take 3 as a critical point, can I do it? Of course I can do it, because if I put x equals 3, then this 3 minus 3 becomes 0, and 0 multiplied by anything is 0. So that's a critical point. 5 is also critical point similarly, because 5 minus 5 is 0, and at this expression this bracket is becoming 0. Right. Okay, so should I include 3 in my answer? No, because it should be greater than 0. It cannot be equal to 0. Similarly, that's why I also can't include 5. Now you see, for all values greater than 5, let's take 6. 6 minus 3 is a positive number, 6 minus 5 is also a positive number. If you check it out, for all values greater than 5, the expression will be positive, which is alright, because we need a greater than 0. That means we need to include all these values, right? We need to include all these values. And you see, between 3 and 5, let's choose 4. 4 minus 3 is a positive number, but 4 minus 5 is a negative number. So negative plus positive will give a negative number. So we should not choose this region, because at this region all the values are negative, which is lesser than 0, but we need a greater than 0s. For values lesser than 3, say 2. 2 minus 3 is also negative, 2 minus 5 is negative. So basically, for values lesser than 3, both will be negative, but negative multiplied by negative will give you positive. So yeah, we should include this region, all this region. So our answer should be x belongs to, this is the symbol for belongs to, minus infinity. Obviously, before infinity we have a curved bracket, parenthesis, comma, 3. Should we include 3? No, because it's greater than 0. If it was greater than equal to 0, then field circle we should have, in that case our answer would have been like this. But no, in this case we should not include 3. Union 5, we should not include 5 again, to positive infinity. This is how you solve it. Basically, once you get the hold of it, it's just a 1 second question. You can just see the question and you can solve it. Okay. And it's always better to approach it in the visual way, by drawing number line and so on and so forth. I'm not drawing this now. Okay. Alright, so let's take this sort of expression where the coefficient of x is negative. I'll cover all types of examples. 2 minus x, and we have x minus 5 greater than or equal to 0. Okay. So basically, you see, you have to multiply minus 1 to both sides. Okay. So this will just be minus times minus x is plus x. So this will become x minus 2. This will remain x minus 5, and this 0 times minus 1 is 0. But with the sign remaining greater than or equal to, no, it will become lesser than or equal to. Now you can solve it in a similar way. Critical points are 2, because 2 minus 2 is 0, and also 5. So for values greater than 5, for say 6, 6 minus 2 is positive, 6 minus 5 is also positive, so this will be positive region. But we should not include this, because in this case we need lesser than values, lesser than or equal to 0. So we should include 2 and 5, that is for sure, because lesser than or equal to 0. So okay, between 2 and 5, say 3 minus 2 is like positive, but 3 minus 5 is negative. Similarly, 4 minus 5 is also negative, but 4 minus 2 is positive. So this will give me negative values. We should include this, because obviously it's lesser than 0. Before 2, see, say 1 minus 2 is negative, 1 minus 5 is also negative. So negative plus negative will ultimately give you positive. So we should not include this value, because we need lesser than or equal to 0. So answer will be x belongs to 2, from 2 to 5, both these values included. Simple answer, right? That's how you solve the inequalities. Okay, let's move on. Let's move on to a bit more complex problem. When the RHS is not 0. X times x minus 5 greater than or equal to 6. X times x minus 5 greater than or equal to 6. See, RHS is not 0, RHS is 6. So what to do? X square minus 5x greater than or equal to 6. That means x square minus 5x minus 6 greater than or equal to 0. In 6 we don't have x term, so we don't need to change the sign here, right? Minus 6 greater than or equal to 0. Can we factorize this? Obviously, because, but yeah, we should arrive at our result 5x by subtracting something from something. So minus 6x plus x is basically subtraction, minus 6 not equal to greater than or equal to 0. So if we take the x common, x minus 6, right, plus if we take 1 common, x minus 6, that means x minus 6, x plus 1 greater than or equal to 0. Now you can solve this, right? Obviously. So what will this be for? Critical points, for here we have minus 6, so plus 6, and here we have a plus 1. So in this case the critical point will be minus 1, because minus 1 is making this expression 0, not plus 1. So okay, for values greater than 6, 7 minus 6 is positive, 7 plus 1 is also positive, so this will be positive region. So we should include this, because we need greater than or equal to. And should we include, say, yeah, 6, because we have greater than or equal to, so we should include the critical points in this case. Between minus 1 and 6, say 4. 4 minus 6 is negative, 4 plus 1 is positive. So negative is positive will give you negative number. So we should not include this. Lesser than minus 1. Lesser than minus 1, minus 2, see, minus 2 minus 6 is negative number. Minus 2 plus 1 is also negative. So negative plus negative will give you positive. So we should include this as well. So what is our answer? X belongs to, x belongs to minus infinity, curved bracket, open interval minus infinity to minus 1, square brackets minus 1 should be included. union 6 should be included, 2 plus infinity or just infinity. That's our answer in this case. Easy. But obviously expressions can be a lot more complex. These we have been considering simple inequalities till now. Okay, so basically let's have this expression x over x plus 4. It's a bit complex, lesser than or equal to 1 over x plus 1. So see, in this case, if it was an equation, we could directly cross multiply. X times x plus 1 equal to 1 times x plus 4. But see, it is not an equation, it is lesser than or equal to. So see, this is very important, you can't cross multiply if you are not sure about sign of term. Suppose I want to cross multiply this term, but am I 100% confident about the sign of this term? No, because suppose if x is a positive number, then the sign of this term will be positive. If x is a negative number, then also the sign of this term, suppose if x is minus 1, in this case it will be 0. If x is minus 2 or minus 3, then the sign will be negative. So as long as I don't know the value of x, I don't know for 100% certainty that what will be the sign of this term. So in such cases we cannot cross multiply. But then what to do to solve this inequality? Because the RHS must be 0, otherwise you can't apply Wavy curve method. What to do is very simple, x over x plus 4 minus 1 over x plus 1. That's all, lesser than or equal to 0. Now you can solve it. This is x, so x times x plus 1 minus x plus 4. Okay, the whole divided. I must take the LCM, x plus 1, x plus 4. Now don't try to distribute it because you need to keep it in this form only when you are dealing with Wavy curve method questions. So this is x square plus x minus x plus 4. So your plus x minus x will just cancel out. And this will become minus 4 after all because we have a bracket here, right? So x square minus 4 is x square minus 2 square, which is just x plus 2, x minus 2. So we have a final expression here, x plus 2, x minus 2 over x plus 1, x plus 4 less than or equal to 0, right? Now see, in this case we have to first of all let's plot the critical points. Plus 2, so minus 2 will be critical point because at minus 2 this bracket is becoming 0. Minus 2 should be include minus 2, of course, because if the numerator is 0, then the expression is 0, and yeah, we have a solution equal to less than or equal to 0, so minus 2 should be included. Plus 2 is also critical point, and that should also be included because it's in the numerator. Minus 1, yeah, minus 1 is a critical point because at minus 1 this expression becomes 0, but should be included? No, because at minus 1 the denominator is becoming 0, and 0 by 0 or any other thing by 0 is undefined, so that cannot be the answer. So yeah, minus 1 is a critical point but open circle, not to be included. Minus 4, yeah, a critical point but not to be included. Now you can solve this thing. Well, now I wanted to tell you something. It's a bit tiresome to every time check, like whether if I choose a value from this part of the number line and whether at this value the expression is lesser than 0 or greater than 0, it's a bit tiresome. So we have a trick for that. Always start with positive. Always assume that the rightmost part of the number line, those values will be positive. And then if the power of the bracket from which this 2 has come, if it is even, then you do not change the sign. If it is odd, change the sign. For instance, 2, I am telling you what it is, what I mean. It may not be clear to you. So what is 2 here? So 2, this 2 from which bracket this 2 has come from? This, no, not this bracket. See, 2 minus 2 is 0, 2 plus 2 is not 0. So from this bracket this 2 has come from. Now what is the power of this bracket? Not the power of x, the power of the bracket as a whole. X minus 2, that's just x minus 2 to the power of 1. So 1 is an odd number. That means I need to change the sign. So this will automatically become minus. If this was say x minus 2 whole square, then it is even number. Then I would have kept it plus. But it is not in this case, so minus. Then consider this minus 1. It has come from this bracket. So the power is again, in this case all the powers are 1, right? So they are all odd. So again there will be sign change. Again there will be sign change. Plus minus, okay? And here again this will be plus. So we need all values lesser than equal to. That means we should include this minus here and this minus here, right? All this plus should not be included. And yeah, so that answer will be x belongs to minus 4 to minus 2. Minus 4 open, not to be included, minus 2 to be included, union, minus 1 not to be included, till 2 to be included. As simple as that. Okay, so we have covered many examples, but now let's do a few more examples. Okay, this is a bit complex situation. Now in this situation we have to consider the different powers. Okay, x plus 1 to the power 4, and we'll solve it like really fast. X plus 3 to that, x plus 3 means to the power 1, just to the power 1. I'm just writing it for confidence because we're doing this the first time. x minus 2 whole cube, I mean x minus 2 to the power of 3, and x square plus 1. Yeah, this is an important example, x square plus 1. So this is the problematic term in this case, and all of this is greater than or equal to 0. By the way, if you have this, if we had an x here, then this could just be written as x plus 0 to the power of 1. Same thing, right? Just for your like understanding. So in that case 0 would be a critical point. Anyway, it's always better to mark 0 the number, and 0 is an important point. Well, anyway, so see this x square plus 1, this is, you cannot factorize this anyway. If this was x square minus 1, then yeah, x square minus 1 is x square minus 1 plus x plus 1, x minus 1. But x square plus 1, you cannot factorize this any further if you see. So what to do? Now in this case, I told you, you cannot cross multiply, never to cross multiply as long as you are not sure about the sign of the expression. But you are actually sure this is always positive. Why? Because x, even if x is positive, suppose if x is positive, x square is positive and positive plus 1 is positive. If x is negative also, even in that case, negative something, you are squaring it, x is squared, then also x squared is positive, and positive number plus 1 is positive. Now I am not going into details of complex numbers, but as long as you are considering real numbers, the value of this must always be positive. So you can, in this case, you can just cross multiply this, and 0 times anything is 0. So just forget about this term, just forget. Now you take the critical points. Minus 1 will be a critical point, because from this bracket, minus 3 plus 3, minus 3 will also be a critical point, 2 will be a critical point, and yeah, that's all we have. So this, mark this positive, 2 has come from this bracket, the power is odd, so there will be a sign change, mark this as negative. Minus 1 has come from this bracket, the power is even, so this will again be negative, there will be no sign change in this case. Mark my words, I mean, I can understand this very nicely. Minus 3 has come from this bracket, so that's again odd, the power is odd, 1. So there will be a sign change positive. So greater than solution include all these positive values, right? Answer will be x belongs to minus infinity, open bracket, till minus 3, union 2 till plus infinity, right? I did not give the bracket because, well, let's check it out. At minus 3, the numerator is 0, so it's greater than or equal to 0, so that's acceptable. So minus 3 should be included. That means square bracket here. 2, at 2, you see the denominator is becoming 0, that is not allowed. Denominator can't be 0, so 2 should not be included. Open bracket here. So that's your answer. You are wrong. You are wrong. In such cases, that's why I say, like, just when you mark the critical points, even before doing this calculation, plus minus minus plus, even before this, you always mark which points to include and which points to not include. You see, the answer is not incomplete, because minus 1, at minus 1 the numerator is 0, which is acceptable. So minus 1 is also a solution of this equation. So minus 1 needs to be included. But yeah, here we don't have a range of numbers. Now how to write minus 1? Don't write minus 1 as an interval. That's not possible. We can't write minus 1 as an interval. We can't write like this, minus 1 to minus 1. It's possible. That's minus 1 to minus 1. Can't write. So just union minus 1 as a set. This is how we represent the elements in a set. If you are not knowing, then in just second brackets. So just write minus 1 as a set, because you can't just, like, minus 1 is not an interval. You can't write like this, minus 1 to minus 1. This is wrong. This is wrong representation. You can't write like this. So in this case, union minus 1. This is the complete answer. If you write till this one, the answer is wrong. Okay. Okay. So guys, solve this question. I know it looks very difficult, but it's actually very easy. Once you apply the concept, I mean, the process might be a bit lengthy. So I'm rubbing this, okay? Because in this case, I need a big number line. First of all, critical points. This here x to the 2016 can be written as x plus 0 to the 2016. Okay, just in case I might keep it like that also. And yeah, x plus 1, this is just x plus 1 to the power of 1, and x plus 6 to the power of 1. That's all. So the critical points. Plus 4 is a critical point, because 4 minus 4, that will make the numerator 0. And that is acceptable. So just mark it now only, at the beginning only. Minus 8 is a critical point. Minus 8. But yeah, that's again acceptable from because that the point is coming from numerator. This is lesser than or equal to 0. Minus 1 is a critical point, acceptable. X plus 0. So 0 is again a critical point in this case, because see, 0 at 0, this is also, this bracket is becoming 0. But it is not acceptable because it is in the denominator, so it's not acceptable. Open circle. X minus 2. So plus 2, yeah, that's also a point, critical point, but not acceptable. Minus 3 is also critical point, minus 3, but not acceptable. 6 is also critical point, but not acceptable. Okay. Minus 9 is also critical point, but again not acceptable. Right. So those values which are acceptable, you must include them in your answer. Even if they are not in interval form, you must write it like this. Just as I showed you in the previous example. Well, that's all now. Come to think of it, positive. Or let's not circle it, just positive. 6 has come from which bracket? This bracket. So power is odd, so this will become negative. 4 has come from this bracket. Power is odd. 2013 is odd. Don't get scared by such expressions. Something raised to the power of 2013. This itself shows that there must be a shortcut, because you can't raise something to the power of 2013 practically and check it, right? And find the value. Well, so anyway, so this is odd, so there will again be a sign change. 2 has come from 2 minus 2. This is again odd. There will again be a sign change. This 0 has come from this. Power is even, so there will be no sign change. Minus for this region, okay. Minus 1 has come from this bracket. Power is odd, so there will be a sign change. Minus 3 has come from this bracket. Power is odd, there will be a sign change. Minus 8 has come from this bracket. Power is even, so there will be no sign change. Minus 9 has come from this bracket. Power is even, there will be no sign change. That's all. Now you need lesser values, right? So yeah, okay, to break this in intervals basically. So all these values should be included, and here we have this. Yeah, so how to write the answer in this case? See, basically x belongs to minus infinity. You can't directly write minus infinity to 3. See, if you write directly minus infinity to minus 3, you might see that this option might seem appealing because it's a continuous all or minus, but you can't do that. You can't, because you have to like also report in your answer about these things. So minus infinity to minus 9 not included, union minus 9 not included, 2 minus 8 included, like you know the basic idea. Then yeah, here also have to do union minus 8 included to minus 3 not included. I know it will be a big answer, but basically the process of solving is easy. Union minus 1 included to 0 not included, union 0 not included to 2 not included, union 4 included to 6 not included. It's as simple as that. But yeah, be very careful when you are dealing with this sign, okay, this sign change, like you know what I mean, plus minus, and that's all. Before ending this video, we'll do one last example, which is a very important example nevertheless. It's a bit different type sort of example, so let's do it. X square minus 6x plus 3 multiplied by x square minus 6x minus 2 is lesser than equal to 50. So obviously, see one thing. I don't know whether these things are factorizable or not, but even if they are factorizable, suppose it's factorizable to something times something, and this is also something times something. Don't do it now, because see, even if you do it, then lesser than equal to 50. So if you write this minus 50 lesser than equal to 0, so this is not in factorized form. All these values multiplied, and then you have suddenly you have minus 50 here. So you have to take into account this minus 50. So don't factorize them now. And yeah, this is a very complex expression, but you see x square minus 6x is a repeating unit. It's in both the brackets. So so assume this is t. So we have t plus 3, t minus 2 lesser than equal to 50. Obviously, to break it, otherwise you can't include the 50. You need to include the 50 in the bracket. So for that, t square plus 3t and minus just a sec, t square minus 2t plus 3t. So that will basically be plus t minus 6 minus 50, that's minus 56 lesser than equal to 0, right? So yeah, RHS is 0 in this case. Now can this be factorized? T square plus t minus 56, obviously, because see, t square 7 just a sec, 8 times 7, so t square plus 8t minus 7t minus 56 lesser than equal to 0. So if you take the t common, t plus 8 minus, if you again take the t common, sorry, if you take 7t common, no sorry, if you take 7 common, we can take the t common here, then t plus 8 less than equal to 0. So t plus 8, t minus 7 less than equal to 0. Now please don't plot the number line, because we haven't factorized from, but only in expression only for t, but we need to solve for x, right? So now you can put the value of t, what we assume to be t, this x square minus 6x. So x square minus 6x plus 8, x square minus 6x minus 7 less than equal to, sorry, not less than equal to 8, less than equal to 0, right? Now these things must be factorizable. Now you can factorize them safely, because our RHS is 0, no problem. So we need a 8. So 6 is just, excuse me, 3 times 2 is 6, or we need a 8 here basically. 4 times 2, yeah, minus 4x minus 2x plus 8. x square minus, we have a 7 here, and so 7, so we need a 6 here. So just 7 minus 1 minus 7x plus x minus 7 less than or equal to 0, right? So you factorize the first expression, x common, x minus 4 minus, we take the 2 common, x minus 2 4 j, right? X minus 4, because of a minus, so we'll have a minus here. Again, if we take the x common, x minus 7 plus, if we take 1 common, x minus 7 less than or equal to 0. That's all. Okay, so x minus 4, x minus 2, x minus 7, x plus 1 less than or equal to 0. Now you can draw the number line. Now everything is in terms of x. Can you see it? I think you're having a bit difficulty in seeing. Okay, don't mind. So this is the last question, so we'll do it nicely. Let me write the expression we achieved once more. X minus 4, x minus 2, x minus 7, x plus 1 lesser than or equal to 0. This is 7 and this is 0. So that's all. Now all you can do is just do this. So what are the critical points? Plus 4. All the parts are 1. 2 is a critical point. Plus 7 minus 1. So let this be 0. So minus 1. So and all these points can be included because lesser than or equal to 0, and we don't have any like rational expression. So denominator, we don't have a denominator. So all these points need to be included. That's all. And lesser than 0. Okay. So this will be positive. So see, basically when you have this type of expression, all the powers are 1. So you don't need to like check it from which bracket this 7 came. No, just put alternate sign. Plus minus. Don't include this, like, okay, minus plus. I just mark the 0, but don't think that these are separate regions. So put a minus here, put a plus here. No, don't do that. Don't do that. Because 0 is a nice thing, but see here 0 is not a critical point. If the expression was like this, x times this thing, in that case you should have marked 0. In that case 0 would also become a critical point, but it's not the case. So, okay, be very careful about these little things. Okay, otherwise that's what is the point of practice. Otherwise the basic thing, it's very easy to cover. The basic thing of wavy curve method. That's why it's called wavy curve method. You see plus minus, it's like get a sort of wave, because minus would represent usually like this, right? Okay, so we need lesser than 0, so that means we should include this minus. So answer is obvious. X belongs to minus 1 to 2, both included. Union 4 to 7, both of them included. So that's all. So the point of this video was to just give you a basic introduction to wavy curve method, and obviously whenever there is mathematics practice is required, but yeah, believe me, it's enjoyable. The mathematics is very enjoyable subject, and so I hope you enjoyed the video, and I hope this video was helpful for you, whoever you are. So that's all for today's video. Thank you very much.